Hello everyone. Note down this question. There are three identical masses forming an equilateral triangle. And side length of this equilateral triangle is L. At the center of this equilateral triangle, we have another point mass M. M shown in black. They are forming an equilateral triangle of side length L. The exact center, right here, we have another point mass M. Find out force acting on this mass. Force on M. Coming from these three masses, what is the force acting on M? Let's see how many of you will answer this. Only one response, and the answer is correct. Total force acting on this M is what? 0. कैसे? देखना. This M is going to pull M towards itself. Similarly, this M will have its attraction on this mass towards itself, and same is the case with the third one. And once I say that this is the center, which is called centroid of this triangle, which is an equilateral triangle, all these distances of this mass shown in blue from all these black points, it will be same. It's an equilateral triangle and this is the exact center, and therefore you have a situation like this. We've got three vectors of same magnitude oriented like this. Three vectors of same magnitude. These angles are 120 each. $120 each. And I hope you remember from the vectors, in this situation, your total force becomes what? 0. Vector sum of these three will be what? 0. If somebody is not comfortable with how come this force, total force will be 0, they can resolve these forces along the horizontal line and the vertical line. This angle is 60. This is F. This is F. This is also 60. So when you take the components, component of this F in this direction will be F sine 60, and in this direction it will be F cos 60. Similarly, component of this F in this direction will be F sine, and in this direction it will be F cos. There are two, and therefore I have added these two components. Now F sine and F sine will cancel each other. Cos 60 is 1 by 2, cos 60 1 by 2, F by 2 plus F by 2, F. This F and this F will cancel each other, and net force will be 0. So very straightforward question. If in this type of setup, where each and every arm is of equal length, it's not necessarily should be an equilateral triangle, it can be a square. You can have a pentagon, you can have a hexagon. If you place a point mass at the center, if they ask you a question like this, that you have a regular hexagon with all these vertices having a point mass m, all these arms are of same length. The question is that find out force at the center. If a mass is placed at the center, then again force on this will be 0. As long as you have a regular structure with all arms of same length, force at the center will be 0. Note down this much. Also note down this second example as a side note. It was an easy question, but only one person could answer this thing. And therefore I'm asking you, if you understand this question completely, then write down yes in the comment box. And if you are still confused, then write down no. Good. Now, again, look at the same setup. 1, 2, 3, 4. Find out gravitational potential energy of the entire system. What is gravitational potential energy of all these four masses taken together as a system? Answer this part. Excuse me. Are taking too long? Let me give you the hint. These are four masses. The hint is this pair, its potential energy is minus of G M M divided by L. 2 point masses, their potential energy is minus of G M by L. This is the hint. Now complete the question. Now how many pairs do you see? 1, 2, 3. And all three are identical pairs, and therefore potential energy being a scalar thing, you can simply add the potential energies as minus 3 Gmm by L. But the question is not still complete. Potential energy of point masses is taken pairwise. So how many pairs do you see? 1, 2, 3. Any other? Yes. Look at this one. 1, 2, 3. These three, their potential energy will be minus of 3 Gmm divided by R. Let's say separation between this and this is R. which you can easily find. You can easily find the value of r. It's an equilateral triangle and you need to find distance of the center from any corner point. It will be this. We need this distance. This is r for us. Draw a perpendicular. This is L by 2. What about this angle? It will be 30 degrees. This is the centroid. Thirty, 30, 30, 30, 30, 30. Now in this right angle triangle, what is cos 30? Cos 30 is L by 2 divided by r. Base divided by hypotenuse, which is r. What is cos 30? Root 3 by 2. 2 and 2 cancelled. Your r is coming L divided by root 3. Put this value of r here and that's your answer. So the question is just to find number of pairs. If you can find all the pairs, then you can answer this question. You can always remember this. Number of pairs it will be n into n minus 1 whole divided by 2. This will give you number of pairs. We have got 4 masses, n is 4. 4 into 3, 4 minus 1, 12 divided by 2, 6. 3 plus 3, 6. All 6 pairs are not identical, but this formula will always give you number of pairs in this type of question. Note down everything. Only one person could produce the correct value. Write down gravitational field. Gravitational field strength or intensity. What is gravitational field strength or intensity? This is something which you already know. It's called G, which is gravitational acceleration. This G, which you have seen so far, is 9.8, which is a special case gravitational intensity of Earth near the surface is what? 9.8. For any mass, if you are interested in finding gravitational field strength or intensity or acceleration due to gravity, then this is G, and we are interested in finding meaning and value of this G. Let's understand the concept first. What is the meaning of G and all? Suppose we have a body, any random body. Let's say its mass is m. Now, if you place a point mass of 5 kg at some distance, what you observe that force of attraction on this 5 kg was 30 newtons. This big body of mass m was attracting this 5 kg towards itself, and the force of attraction was what? 30 newtons. Now the question is, if instead of 5 somebody comes and places 7 kg mass exactly at the same spot, same point, let's call it point P. If you replace 5 kg with 7 kg mass, then what is force on 7 kg coming from this capital M? Let's see if you can answer this or not first. Try to answer this part. What is the force on this 7 kg block? Look, nobody has produced the correct value, and just because of that we introduce the concept of gravitational field strength. We have the information that if you place 5 kg block over here, then force on 5 is 30. If I remove 5 and place 7 kg, question is find out force on the 7 kg block. So what I did, on 5 kg, force is 30. On 5, force is what? 30. Now if I ask you what will be the force on 1 kg? Answer will be 30 by 5, which is 6 on 1 kg. This 1 kg is called unit mass. On 1 kg force is what? 30 by 5. On 1 force is 6. And then if I ask you what is force on 7 kg, then I hope you know that. Answer will be 7 into 6, which is 42. So force acting on this 7 kg, if you place it at P, will be 42. Force acting on the 7 kg block. For blue 7 kg, I am using blue arrow, or you can draw a separate figure. The force is coming 42 newtons. Now, what is the advantage of the whole process? If I can find force on unit kg, 1 unit. If I can find force on unit mass, then for any other mass, I can easily find the force by simply multiplying 6 by the mass of the body on which you need the force. This intermediate step, every time we are given an information like this, we have to go through this intermediate process step. If they give us mass on any body, to find mass on some other body, you need to repeat this process again and again. So what we did, instead of giving information in the form of force on mass 5 kg or force on mass 7 kg, they give us force on a unit mass. Force on a unit mass. If you have the information of force on a unit mass, then you can easily find force on any other mass. यहाँ पर किसी ने एक इंफॉर्मेशन आपको दे दी that if you place a unit mass 1 kg at point P, then on 1 kg force will be 6. Now somebody comes and places a mass of 3 kg. Then what will be the force on 3 kg mass? On 1 it is 6, on 3 it will be 6 3 is 18. So this place has now a special thing. If at a particular distance from a given mass body you place a unit mass and you can find the force on the unit mass, then this force on unit mass is given a special name, and that name is what? G. Next time they will give you an information like this. At P, G is 6 newtons per kg. At point P, strength of gravitational field, intensity of gravitational field is what? 6 newtons per kg. If they give you an information like this, then it simply tells you what? On 1 kg, force is 6. So gravitational intensity is nothing special. It is still what? Force, but force on a unit mass. फिजिक्स में हर जगह पर हम यही चीज करते हैं. Instead of giving you an information like this that in 10 seconds object is going to move 20 meters, we'll say that its speed is 2 meters per second. So saying this, that in 10 seconds object is going to move 20 meter, rather say what? Speed is what? 2 meters per second. That is, in 1 second the object is going to move what? 2 meters. Or again, instead of saying that an object has this much mass for this much volume, we simply define what? Density. What is density? Kg per meter cube. For unit volume, you're defining what? Its mass. So if you can find something for unit mass, you can easily find mass, force, or distance traveled for any other time interval, volume, and in this case another mass, body. Note down this much basic information and then we'll write the whole format in a proper manner. By the way, if you understand the use of G, why it is introduced, if you understand this, then write down yours in the comment box. Write down the statement. Gravitational force acting on a unit mass, gravitational force acting on a unit mass at any point is called intensity of gravitational field, at that point. Look here. Now let's not talk about 5 kg, 6 kg. Let's say we have a point mass m. This m is the point mass. Why it should be a point mass? Because we need gravitational intensity at this point P. So at a point if you want gravitational intensity, then you should place a point mass. If you place a cylinder like this, then the cylinder is occupying several points. So the question is, we need to find gravitational intensity at point P near this body of mass m. The moment you place m, we found that force acting on this m is F. Force is a vector, so use F vector. Now, how do I define G? What is G? Force on a unit mass. On m, force is F. So on a unit mass, force will be what? F divided by m. That's very easy. Same thing. We found force on 5 kg and then the intermediate step. So on m, at this point, force is F. So what will be the force on a unit mass? Look at the advantage of this technique. You don't have to bring a unit mass. अपने को कहीं से unit mass search करने की जरूरत नहीं है. जो भी mass आपको मिल जाए आप लेकर आओ. Find force on that. And once you find force on that, divide the force by the mass, which will give you what? Force on a unit mass. At the moment you have got force on a unit mass, अब आपके पास एक इंफॉर्मेशन आ गई कि इस जगह पर, इस पॉइंट पर आपने कभी भी कोई यूनिट मास रखा तो उस पर कितना फोर्स लगेगा? G. This information now can be used with any other mass. किस तरह से देखना यहां पर? First of all, what is G? Basically force. किस तरह का force? Force on a unit mass. What is force? A vector. And therefore G is also a vector. From this, you can see the familiar format. You can write force as what? Mg. So when we say that weight of an object is mg, it's coming basically from this presentation. G is F by m. What is G? Force on a unit mass. Since this is force on a unit mass, its unit is what? Newton per kg. Newtons per kg. But force upon mass, you know, is what? Acceleration. And therefore this Newton per kg, or the familiar unit of acceleration, which is meters per second square. So what is the unit of G? Newton per kg or meter per second square. If we have G at a given point, we can also find force at that point. And when we'll take few examples, you will understand the whole concept in a much better way. As of now, note down this much information. Let's understand the whole concept in a much better way. Write down the heading gravitational intensity of a point mass. Gravitational intensity of a point mass. This body of mass capital M, which was of any irregular shape, now we are saying is a point mass itself. This is your point mass. This is the body whose gravitational intensity is required at a distance of r from it at this point P. This is the body. So what we did, to find gravitational intensity at this point, you will bring a point mass M. This is point mass M. This is another point mass. If they both are point masses, then what is force? Force, first in the magnitude form, it will be Gmm divided by r square. In the original example, when I had an irregular shape, we cannot use this formula. This is used only when both this as well as this are point shapes. So this M is attracting this M towards itself to the force of Gmm by r square. But I've been asked G, gravitational intensity at point P due to mass body M. मतलब क्या है इसका बता दिया मैंने कि किसी ने बोला है कि what is gravitational intensity at point P? In simple words, it only means this: if you place 1 kg mass at point P, then how much force capital M is going to apply on this 1 kg mass? Whole thing in short is find out G. So what is G? Force divided by M. On small m, this much is the force. And therefore on unit mass, what is the force? F by m. What is F by m coming? G m divided by r square. What is this? Gravitational intensity of a point mass at a distance of r from it. Gm divided by r square. Write down this. Now, let's write down its vector form. This G In the very first lecture of gravitation, I told you how to write force in vector form. So let's not waste time. This force in vector form was GMM divided by R square minus of R cap. The force, this gravitational force, its vector form, I hope you remember, and if you do not, then just go and see that lecture. What is R cap and minus R cap? A brief introduction. This is capital M, this is point P, this is R vector. This is R vector. R vector is from this point to this point. This means this particular direction is R cap. Suppose we are interested in the horizontal case along the x-axis. Then this R cap is nothing but I cap. If instead of this you are interested in finding gravitational field or force at this place, then your R cap will be simply what? J cap. From this position to this position, this is R vector. Not this. Any direction which is in parallel to R, any direction which is parallel to R is given by what? A unit vector. This R cap is a unit vector. And how do you find unit vector? Divide the vector with its own magnitude. 10 divided by 10 is what? 1. 5 divided by 5 is what? 1. So this direction has a special name which is R upon R or R cap. What is the meaning of negative sign? This capital M is attracting P, attracting mass M in this direction. What is this? R cap. And therefore what is this? Minus R cap. And how do you present a vector? For presenting a vector, we need two things. One, which gives its magnitude. So this is the magnitude part. And this magnitude has this direction. So once somebody looks at this, it gives you two informations of the magnitude and that of the direction part. So if you now need G, look here, you need to simply divide force by mass. Force by mass. So right at this point, if somebody says find out G in vector form, the answer will be what? G M divided by R square. This is magnitude. What is the direction? Minus of R cap. So this is the vector form of G, this is the magnitude form of G. Again, what is the meaning of G? Force on a unit mass. This is the magnitude. So if I ask you what is the force, what is the magnitude of force on a unit mass, you will say this. किस तरफ लग रहा है? आप बोलोगे कैपिटल M की तरफ. Mathematically it is minus of r cap. So those who have not seen the vector form, it's a fast revision. Note down everything. इतना देखकर हो सकता है कुछ लोग कंफ्यूज हो गए हो, पता नहीं क्या डिफिकल्ट फॉर्मेट बना हुआ है. Well, nothing is difficult. You just need to understand that gravitational intensity, it only is force on a unit mass. देखना, अगर कभी कोई कंफ्यूजन बने भी, किसी ने बोला कि इस एम का अपने से आर डिस्टेंस पर, देखते हैं ना, इस एम का अपने से आर डिस्टेंस पर कितना ग्रेविटेशनल फील्ड है. अपने से पूछा गया व्हाट इज जी. आपने अपने दिमाग में क्या रखा, जी का मतलब होता है फाइंड फोर्स, बट दिस फोर्स शुड बी ऑन यूनिट. तो अगर यहां पर हम क्या रखते हैं, यूनिट, तो इस यूनिट पर जो फोर्स लग रहा होगा उस फोर्स को ही आप क्या बोलते हो, जी. अगर ये 1 की जगह 2 होगा, 5 होगा, वैलिड नहीं है. अब 9, 10 से आपको पता है, दिस इज m1, दिस इज m2. व्हाट इज फोर्स on m2 coming from m1? G m into 1 divided by r square. Kadam. Gm by r square. So what is gravitational intensity or field strength or acceleration due to gravity at a distance of r from a point mass m? Answer is gm by r square. And what is direction of this? Direction का मतलब क्या, किसकी डायरेक्शन पूछी है, ग्रेविटी. ग्रेविटी का डायरेक्शन किधर होता है, फोर्स के डायरेक्शन में. फोर्स कहां लगेगा, towards capital M, and therefore you also have the information of direction. तो जितनी भी चीजें अभी तक अपन ने की हुई है, this is all present in this simple presentation. उसको भी नोट कर लो. Now let's see how many of you will answer this next part. Look here. We have three identical masses of m each, forming an equilateral triangle. What is intensity of gravitational field at its center? Write down the answer. खत्म, केवल इतना सा है। थोड़ी देर पहले हमने क्या निकाला था? हमने यहां पर एक मास m पर क्या फाइंड किया था? फोर्स। What was that force? 0. If you place a mass over here, force on that mass is what? 0. If force on any mass is 0, then force on unit mass will also be what? 0. And therefore, what is the answer? 0. केवल इतना सा है। जो आपने फोर्स पे किया हुआ है वही आप यहां भी फॉलो कर रहे हो। Another example. Let's see how many of you will answer this thing fast. We have got 16 kg and 25 kg separated by a distance of 27 meters. At what distance from 16 kg? At what distance from 16 kg gravitational field due to 16 and 25 becomes 0? At what distance from 16 total gravitational field due to 16 and 25 becomes 0? Answer this in just 20 seconds. Good. So what we have done in previous lecture, this is M1, this is M2. At some distance x from 16, if we place a mass m, something which we have done in the previous lecture, m1 and m2, between m1 and m2 at a distance of x, if you place m such that x is root m1 r divided by root m1 plus root m2, then force on m becomes 0. ये हमने किया हुआ है कि अगर इस m पर x पर रखोगे, where x is this, force will be what? 0. On m force is 0, but the question this time is what? At what distance g is 0? तो भाई जहां फोर्स 0 होगा वहीं पर फोर्स ऑन यूनिट मास भी क्या होगा? 0. And therefore x is root m1 16 4 27 4 plus 5, which is coming 12 meters. सेम फॉर्मूला जो फोर्स के लिए था वही किसके लिए है? ग्रेविटेशनल इंटेंसिटी के लिए भी. Note down this. Now answer this. M, M, 2M, forming an equilateral triangle. This time all three are not same. These are same MM and this is what 2M. What is gravitational field at the center? Let's see how many of you will answer this. There are 3 point masses forming an equilateral triangle and masses are mm, 2m. What is gravitational field at the centroid? Good. 2 responses. One is completely correct. Another one is partially. Wait a second. None is completely correct. None is completely correct. So, this whole setup is what? The whole setup is equivalent to this. M, M, M. This is not M, this is 2M. So let's place another M. M and M both are occupying this position, that gives you what? 2M. Now, what is gravitational intensity due to M, M, M? These black masses at the center. Due to black, everybody knows G will be 0. Black, 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 black. आप जो भी कलर यूज करना चाहें. लेकिन ये जो M है, तो ये तो यहां पर क्या देगा? Gravitational intensity. What is gravitational intensity? Force on a unit mass. Now forget that. अब तो अपने को formula पता है. If this much is R, वो हम पहले कैलकुलेट कर चुके हैं. Then gravitational intensity at this point due to the blue mass is G, and what is that? G m divided by r square. So gravitational intensity of the centroid due to m is 0. तो किसकी ग्रेविटेशनल इंटेंसिटी बची हुई है of this additional mass m? This m is a point mass at a distance of r. What is gravitational intensity? Gm by r square. And the answer which I got, and I told you that they are partially correct. People are using gm square. No, this is gm only. Once I say gravitational intensity, this is force on a unit mass. So this is your G, which is gm by r square, and I hope you remember this r was L by root 3. So what is the answer? Gm upon L square by 3. In complete form, if I ask you what is G total, if somebody says present the answer in complete vector form, what is gravitational intensity over here? The answer is what? Magnitude is this much. This is I cap. What is this? J cap. J cap. That's the answer. कुछ स्पेशल नहीं था, थोड़ा सा सोचना था, and you can complete this type of thing. Those of you who understand this completely, write down yes in the comment box. A similar profile again is a regular hexagon. This regular hexagon has 5 masses, identical, and the 6th place is empty. One, two, three, four, 5. 5-point masses, and the 6th place is empty. Find out gravitational intensity at the center. Let's see how many of you will produce a correct answer. And technically it should take only 30 seconds. For those who cannot find distances and all, if you have a regular hexagon, then distance of center let's say this distance is r, 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 regular. It's a regular hexagon and therefore all these angles are of 60 degrees each. What is total? 360. 1, 2, 3, 4, 5, 6. 6 identical partitions of 360. Each will give you what? 60. Now, what is this distance L? It's a regular hexagon and therefore, look at this triangle first. Look at this triangle. This triangle is an isosceles triangle. R and R. It's a regular one and therefore distance from this corner or distance from this corner, they both are what? Same. That gives us two arms of same length, an isosceles triangle. Now if it's an isosceles triangle, then these two angles, they should be same. Base angles. These are same, but this is already 60. तो फिर ये दोनों क्या हो सकते हैं? 60, 60. That's the only option left. This is 60 and this as well is 60. Now, since all three are 60, it becomes an equilateral triangle. And if it is an equilateral triangle, then you got the value of R as what? L. So R is coming what? L. Now what do I need R? अब यहां देखना, अगर मैं देखना मैं यहां पर अगर मैं इस जगह पर द एम्प्टी पोजीशन यहां पर अगर एक एम रख दूं, समझना, with this m also occupying the position, these 6, their total gravitational field will be 0. G of all 6, just so that you can understand, 1, 2, 3, 4, 5, 6, G of all 6 will be 0. Why? I told you that if you have a regular structure, then at the center force will be 0. If force is 0, gravity is also what? 0. इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि जो सिस्टम है ये इसकी इक्विवेलेंट है. ये जो जितने के ब्लैक मासेस हैं, अपने को ग्रेविटेशनल फील्ड किसका फाइंड करना है? ग्रेविटेशनल फील्ड किसका फाइंड करना है? 1, 2, 3, 4, 5. हमें किसका ग्रेविटेशनल फील्ड फाइंड करना है? G ड्यू टू 5. दिस इज नॉट प्रेजेंट, हमने इसे रखा हुआ है अपनी तरफ से. लेकिन अपने को एक चीज मालूम पड़ गई है क्या, कि ये जो ब्लू है M ऑन टॉप, इसका यहां पर इस ब्लू का अपने से R डिस्टेंस पर, विच इज L, जो ग्रेविटेशनल फील्ड होता इस ब्लू का यहां पर कितना होता? G M डिवाइडेड बाय L स्क्वायर. दिस इज R विच इज L. ये ब्लू यहां पर इतना देता. ये जो ब्लैक है, क्या इनका ग्रेविटेशनल फील्ड क्या इनका ग्रेविटेशनल फील्ड इधर कहीं हो सकता है टोटल कंबाइंड 1 2 3 4 5? नहीं. क्यों नहीं हो सकता? Because all 6 the field is what? 0. That means this thing should be completely cancelled. If you say it is completely cancelled, then it is possible only if you have gravitational field due to all 5 in this direction. In this direction. And this arrow, this gravitational field vector and this gravitational field vector, they should be of equal magnitude. क्यों? तभी जाकर ये दोनों एक दूसरे को क्या करेंगे? कैंसिल, and total field will become what? 0. अपने से क्वेश्चन में क्या पूछा गया था? अपने से क्वेश्चन में पूछा गया था that we have masses present only at these positions. This place was empty. पूछा किससे गया था अपने से? 5 का. लेकिन वो 5 किसके बराबर दे रहे हैं? A single one. जो G अपने से 6 का पूछा, 5 का पूछा गया है, this G of 5 is basically equivalent to G of 1 only. And G of 1 is what? G m divided by L square. Now remember, what is the direction? Not this. तो ये प्रेजेंट नहीं है. किसका फील्ड पूछा गया था अपने से? 5. कहां है वो? डाउनवर्ड्स. So what is the direction? Minus of J cap. Hopefully समझ में आया होगा. Those of you who understand this, write down yes in the comment box, and if you do not, then write down no in the comment box, and then you can leave. Thank you very much.